Alright guys, 7.5, we're taking the derivative of logs. So remember we did derivatives of e to the x or exponential. The derivative of e to the x is e to the x. Well, now we need to do the inverse. So in 7.3 we learned about the inverse functions and their derivative. Remember, it's the reciprocal. So this is a proof about how if we did the derivative and inverse, we would get 1 over x for ln. So some of you are already played around with this because of our derivative packet. So the derivative of ln is 1 over x, but don't forget, if we have something other than just x in our ln, we also have to take the derivative of the inside, like the chain rule. When we do a log base of something, we have 1 over x. That's where our ln comes in, but then we also have to take the ln of that base. Do not forget that this is a constant number. Okay, it's a number value. So let's go through our derivatives. So y prime equals, the first thing we're going to do is go 1 over our inside, because that's our ln part, and then we multiply by the derivative of that inside, chain rule. So derivative of 5x is 5. If we multiply that through, those 5's cancel. So we have the derivative of y is 1 over x. Number 2, f prime of t. First thing I'm going to do is the derivative of that ln, which is 1 over 3t squared minus t. Then I have to do the derivative of the inside, which is 6t minus 1. We cannot simplify that any further, so I'm just going to write it as one fraction. So 6t minus 1 over 3t squared minus t. Alright, number 3, be careful here. We do have an ln, but we have an extra x out front that we are multiplying by. So we need to think of the product rule. So I'm going to make u as x and v as ln x. So du is 1, dv is 1 over x. So h prime of x, u times dv plus v times du. And then I'm going to simplify that. So h prime of x equals, well, x times 1 over x is 1, and 1 times ln x is ln x. And we are done. Alright, so this is having us graph ln absolute value of x, but the truth is we can do this without a graphing calculator, because ln of x is just going through 1, 0, and the asymptote being at 0. Now, because we are taking the absolute value of the inside, remember how to do that is to get rid of the left side, which there's nothing on, and then reflect the right onto the left. So technically our graph will be on both sides. Now, how can this happen if we can't take the ln of a negative number? Well, if we plug in a negative x, guys, what happens there? it becomes positive before we do the ln. So what this is showing you guys is that when we have the absolute value, it's still 1 over x when we take the derivative. It doesn't matter. Some of you are very confused when we did the derivative packet before if the absolute value did anything to the derivative, and this is why it doesn't, because we still have the same function. Okay, so let's turn our page over and do some more practice problems. Alright, so even though we have an absolute value, it's not going to distract us anymore, okay? So we're going to take the derivative. So we have 1 over 5 minus 2y cubed times the derivative of the inside is negative 6y squared. And then as you can see, the only thing we can do is put that together as negative 6y squared all over 5 minus 2y cubed. And we're done. Alright, example 6. There's a lot going on here. Everything that we have been writing or doing the derivative of ln is only a numerator over 1. And in this case, we have so much in the numerator divided by something other than 1 in the denominator. So actually, we're going to rewrite y first before we take it. Now, if you remember, what does division mean when we separate? Division means subtraction. So right now we have ln x square root 2x plus 1 minus ln x squared plus 1. I want to make sure that you put that in parentheses to know that's all in the ln. Now, if we were to take the derivative right from here, which would be the derivative of this one, derivative of this one, we would have, again, it would be a right answer, but we're still having to do a product rule then. But what does multiplication mean when we expand? It means addition. So I could say ln x plus ln square root of 2x plus 1 minus ln x squared plus 1. And now I can take the derivative of these 3 parts, and that's a little bit simpler. So let's take that derivative. What's the derivative of ln x? 1 over x plus, what's the derivative of this second ln? Well, let's do this. 1 over square root of 2x plus 1 times the derivative of this, right? So let's remember this is 2x plus 1 to the 1/2. So that's 1/2 times 2x plus 1 to the negative 1/2. It has a chain rule in there, so times the derivative of 2x plus 1, which is 2. Okay, if you have to, guys, do that on the side. Do 2x plus 1 to the 1/2, and then do that derivative. Okay. And then we have this minus 1 over x squared plus 1 times the derivative of the inside, which is 2x. Okay, I'm going to simplify that a little bit. So 1 over x stays the same, plus, well, this 2 and this 1/2 become 1, so it's like they cancel. This comes down below, right, as a square root. Well, what's the square root times the square root? It gets rid of the square root. So it's 1 over 2x plus 1 minus, and this can't be simplified, so we're just going to put it together as 2x over x squared plus 1. Alright, so right here it's proving to you about why the log basis. So I do want to go through this so that way you can see where we're getting 1 over x ln a. So first let's change this base. So going back to the other page where you, let's see, where was it? Sorry guys, the light went out again. Where's our change of base? Right here. When we said the change of base, you can also do it as ln's. So we're going to change this base as ln's. So what we're looking at is the derivative of ln x over ln a. So that's just reformatting this piece. Okay, remember this is a number, so it stays there. And then what's the derivative of ln x? Well, it's 1 over x. So that's where it's coming from. Okay. Now we have a y equals log base 2 of x squared plus 1, and then we're going to evaluate y prime of 2. Remember, what are a couple things that this means? Well, if we're finding the derivative at 2, we're finding the slope at 2. So, excuse me. Well, excuse me, guys. Y prime equals 1 over x squared plus 1. Remember, times our ln of the base, which the base is 2. Now we have to remember chain rule though, because we have an inside here. What is the derivative of the inside? 2x. So let me condense that. I don't know why I put d down there. I think I was thinking dy dx. Y prime equals 2x all over x squared plus 1 ln 2. Now I'm just going to do y prime of 2 and plug in 2 for x. So I get 4 all over, let's see, 2 squared is 4, plus 1 is 5, ln 2. And we are done. Thanks, guys.